Good evening. Welcome to module Communication Theory, Learning Outcome 1. So, in this video, we are going to discuss the one example for cumulative distribution functions. Roughly, we can say that cumulative distribution functions is nothing but the process of accumulating the frequency functions in ascending order. So, example, a certain honest wheel of chance is divided into three equal segments, which is colored green, red, and yellow, respectively. You spin the wheel twice and take the outcomes to be the resulting color sequence GG, GR, RG, and so forth. The colors are assigned with the numerical weights G equal to 2, R equal to -1, and Y equal to 0. And the random variable X is taken as the average of the weights observed on the given trial of two spins. The question is find and plot probability function and the cumulative distribution function CDF. So you can see here the diagram shows the spinning wheel. It is divided into three segments. So the color green indicated by G, red indicated by R, and yellow indicated by Y. Okay, so now assume that we are spinning the wheel one time. So there may be chances for green or red or yellow. So the sample space which consists of the three possible outcomes, that is G, R, and Y. Now, consider we are spinning the wheel two times, twice. So, so after two times, the sample space which consists of the nine sample points or nine outcomes, which is varies from GG, GR, GY, RG, RR, RY, YG, YR, YY. So now, so we need to map the the sample points into the numerical value. For example, you can take the outcome Ry, then by mapping the x of Ry, which is equal to -1 plus 0 by 2. So the -1 is the weight of the red, 0 weight of the y. Because of, we need to find out the average weight, so divided by 2. So it will give the numerical value for the outcome Ry in the random variable x, which is equal to -0.5. In this same way, we need to find out the numerical values for all the sample points in the sample space. So which is denoted by x of x. So the random variable x, which consists of the nine numerical values. And we can observe from these resulting numerical values, some of the values are common, like there are 2 times 0.1 is coming, and 2 times -0.5 is coming, and 2 times 1 is coming. So we can combine that numerical values into single number, and then arrange in ascending order. We are getting that the random variable numerical values x of s is equal to -1, -0.5, 0, 0.5, 1, and 2. So totally 6 numerical values generated in the random variable x for the sample space. Yeah, sample space, yes. Okay, but the sample space which contain the nine outcomes, but the random variable which consists of only 6 numerical values, because some outcomes are common for the some outcomes are mapping to the single numerical values. You can see from this diagram. So there is a sample space, yes, and the real line xi, and then the frequency function p of xi. So in the sample space, there are 9 possible outcomes present. Okay. So the first, the outcome RR is mapped to the -1 in the real line. And then you can see that RY, YR outcomes, these two outcomes are mapped to the -0.5 in the real line. Okay. Similarly, YY mapped to 0, RGGR mapped to 0.5, GYRG mapped to 1, and GG mapped to 2. So in that way, all the sample points in the sample space are mapped into the numerical values in the real line. So and it is arranged in the ascending order from -1 to 2. So after getting that numerical values, so we can find out the what is the probability function for that numerical values p of -1, p of -0.5, and so on up to p of 2. So that is the p of xi or we can P of x we can call it as frequency function or probability function. Okay, so we know that the probability of occurrence of the event RR is 1 by 9 because there are 9 possible outcomes. So for each outcome, it assumes that all the outcomes are maintaining equal probability, so that for each outcome the probability is 1 by 9. So that we are getting for minus 1 by 9, but for minus 0.5 numerical value, the frequency function is a 2 by 9 because there are two outcomes. Two outcomes are mapped to the minus 0.5. So 2 times 1 by 9, which is equal to 2 by 9. Similarly, all the numerical values are mapped. All the numerical values, probability functions are calculated. So here that mathematical equation for the frequency functions are given, which is varies from px of x1 to px of x6 because of totally 6 numerical values present in the random variable x. Then the corresponding CDF function will be calculated, which is denoted by fx of x1 to fx of x6. But the CDF function for every ascending order that frequency function will be accumulated. So for first fx of x1, we can directly take the probability function px of minus 1, the first point in the frequency function. But the fx of x2, we need to add the two frequency function, that is fx of px of minus 1 plus px of minus 0.5. So in that way, for every numerical value, we can accumulate the frequency function in ascending order. So for the last numerical x6, the CDF function is fx of x6, so which is equal to fx of 2. In that, we need to add all the frequency function from px of minus 1 to px of 2. So by adding all the frequency function, it will be equal to 1. So here it shows the graphical representation for frequency function and the corresponding CDF function. The x-axis represent the numerical values of the random variable x, which is varies from minus 1 to 2. And the y-axis shows the value of the frequency function px of xi. Okay, so for minus 1, the value is 1 by 9, minus 0.5, it is 2 by 9, so and so on. Okay, it is plotted. Okay, and in we see the CDF function, the starting point minus 1, it has the 1 by 9, and the second point minus 0.5, we need to add the first and the second frequency function. So 1 by 9 plus 2 by 9, which is equal to 3 by 9. Then the CDF of 0 is adding the three frequency function, that is 1 by 9 plus 2 by 9 plus 1 by 9, which is equal to 4 by 9. And for 0.5, the CDF function is by adding that 5 frequency function. I mean the 4 frequency function, that is 1 by 9 plus 2 by 9 plus 1 by 9 plus 2 by 9, which is equal to 6 by 9. Similarly, we need to find out all the CDF function for the numerical values of the random variable. But the last numerical CDF function for the numerical value of random variable is 2. So for that CDF function will be equal to 1. This is the maximum value of the CDF function. Okay, thank you. So in this video only, we studied about the example for the CDF function using spinning wheel.